Let's start the session. Good afternoon, one and all present here. On behalf of Vistas Department of Computer Applications, I welcome you all the participants for this wonderful session. Okay, I am sure that you all will feel enriched with knowledge after completion of this session. Okay, so I am now so grateful to welcome Dr. Asha, Senior Associate Professor, School of Computer Science and Engineering, VIT, Chennai campus. Dr. Asha, working as your Associate Professor Senior in the School of Computer Science and Engineering, VIT, Chennai. She is having nearly 15 years of teaching and research experience. She completed her PhD from Anna University and MTech from SRM University in Computer Science and Engineering. She is now nearly 35 plus research publications to her credit. Her research area of interest includes biometrics, network security, IoT, and cyber physical systems. She is also a faculty member of Center for Cyber Physical Systems at VIT Chennai. She has produced 2 PhD scholars and currently guiding 4 research scholars. It's my pleasure to welcome Dr. Asha once again. Ma'am, it's your time. You can take the session.
Okay, thank you.
Yes, ma'am. Welcome, ma'am.
Okay, ma'am. Thank you very much for the brief
Yes.
introduction.
Okay.
Thank you so much.
Yes, ma'am. You can take over the session.
Okay. Okay, thank you.
Yes.
Good afternoon, all. I'm very happy.
Yes, ma'am. You are audible, ma'am.
Yes, okay, fine. I'm very happy to be a part of this national level online 5 days FTP on role of Industry 4.0 in research and higher education, conducted by Vels Institute of Science, Technology and Advanced Studies. Very good afternoon to one and all present over here. Okay, I hope all of you are able to hear my voice.
Ma'am.
Okay, fine. Thank you so much. So my topic today's topic is cyber physical systems and Industry 4.0. So when we are talking about this cyber physical system,
Ma'am,
okay,
could you
this
change
is
the
one of the
slide to full
key
screen?
element in the
Ma'am?
full screen only. It is there. 1 minute.
Yes,
I'll
okay.
stop sharing and again do it.
Slideshow, ma'am. Slideshow, ma'am.
Okay, okay. Okay. Your entire screen. Entire screen. Example, I can take that. For example, there is the automatic switch. Okay, so in that switch, when the time is 6 p.m. or something, the lights should switch on automatically. So in that case, switch is also one component. There is a sensor to view the light source, and then it is going to actuate the switch on process. Like that, some computing process is also involved, and also some embedding devices is there. Uh, and sensors are capturing the devices, and there is some communication between the devices also. So everything happens. So it is going to be an integration of different systems with different natures. All is not going to be of same thing. So everyone, like communication means through networks, it can be a wireless communication or wireless communication I'll be having. So actuator, it is going to be like a switch on or off, or it is going to send some message to the mobile, or it is going to trigger some activity like that. That actuator work will be there. Storage means whatever data we are collecting, we'll be storing it in some way to perform the computation. Okay, this process is going to be repeated for a particular application. So in this case, the term physical refers to the object as it is perceived by the human senses. So we know that whatever we are able to touch and feel, we call it as a physical object, while the term cyber refers to the virtual representation of the world in which the physical object belongs, while providing further details about the object. For example, its make or a model. For example, I can say that there is a car, smart car. I can feel it. It is the physical thing. But if I wanted to know something more in detail, it is going to be an automated car, like it is going to communicate some information to the car which is moving far behind it, or uh, moving before it, or to a control room or something. So those things comes under the cyber part. Okay, so we can consider this like a cyber physical system. When we consider this, it is initially coined by Ellen Gill in the year 2006. Okay, the cyber physical system, or it is called as a smart system. It is an integration of computation, networking, and physical processes. It is the definition of Berkeley. So, when we consider this interaction between the cyber world and the physical world together, we call it as a CPS. It is conceptually an embedded system plus physical system. For example, we can consider a washing machine or a fridge. Nowadays, we are having smart fridge, smart washing machines. Everywhere we are having some embedded things, and it is a physical device, and there is some computing involved in it to do something automatically. And it is also having some software working inside the hardware, okay, to make it more smarter. So there is a hardware device. If I wanted to uh, perform that hardware, make that hardware device more smarter, I have to include some software involved in it, so that it can be made smarter. So what is the data or information software which I'm going to do means, I'm just going to feed data. That data is going to be a trained model one, which will be learning on its own, and based on that, it is going to make that particular hardware a smarter one. And we are going making to use this for computing, communicating, and also for controlling the application. So when we communicate to the physical world through the sensors and actuators, it is going to be a kind of automated thing. So for example, we can take that vehicles, aircrafts, radar, medical instruments, robotic equipments, process monitoring, and factory automation systems. These are all comes under the cyber physical systems. So when we take the computing part, we can say storage, processing, communication comes under the computing part, and the rest of the things are going to be a physical system. So you can, as a whole, pictorially, I can represent the cyber physical system like this. We are having a physical world, and we are having a cyber world through the Internet of Things, IoT of Things, and with the help of the Internet, we will be able to make the application a smarter application, or a device as a smarter device. Nowadays, you see that a smartwatch, smartphone, everything is going to come with the word smart. Why it is called a smart means, it is performing certain activities smarter rather than the normal device. So it is called as a smarter one. So when we take this physical world, we can have wireless devices, antennas, mobile phones, buildings, factories, automobiles, everything comes under the physical world. So all these physical world objects are made to do some sensing. We will be having some sensors inbuilt in that. With the help of the sensor, we will be getting data. The data will be sent to the cyber world for processing through the uh, internet. Okay, so it will be served in some servers, and it will be served in some databases. And also, apart from these data, we can get data from the cyber world also. From the cyber world means, like through the social medias, we can get as much data as possible. So with the help of this data, we are just processing this data, and we are gaining some knowledge out of this also, and that can be performed as an action in the cyber world. And for the data which is obtained from the physical world is going to be processed in the cyber world, and actions will be performed again on the physical world. For example, when an automobile, for example, a car is moving, and it is sending some data, like the information, the geo information about that location, everything means, based on this, it is going to be processed. Suppose if there is some traffic jam which is going to come in 1 kilometer or half kilometer, means it is going to predict that thing, and it is going to pass on to that vehicle, and this car which has sent the data will be receiving this, and based on that, it is going to take some action. Okay, this is also why this is actually happens in cyber physical systems. But how it works, how the cyber physical system works. Normally, the data, whatever we are getting the data, it is the directly record physical data using the sensors and affect physical processes using the actuators. So whatever data we are getting it through the sensors are going to be the uh, data which is going to be passed on to the processing part. It has to be evaluated, and sometimes these data will be recorded for future use, and based on that we will be doing it actively or reactively to interact with the uh, physical and also with the digital world. So when we are connected with one another in the global network through this digital communication facilities, we will be able to do this active interaction of the data. So normally these data and services are globally available. So the human and machine interfaces are going to be a multimodal human machine interfaces, which is going to be a series of uh, dedicated activity. Up to this, you're all following. Shall I move on to the next?
Yes, ma'am. Yes, ma'am.
Okay, okay, thank you so much. Okay, so we are talking about this cyber physical system. Cyber physical system. What is the global idea or notion about the CPS market means? You can see from this, like from the current year 2021, it is predicted it is going to increase in the nearly 8 years. You can see the increase. It is predicted like this in the various parts of the world, how the global cyber physical system market will be there. Though we are having so much market for the CPS, still there are some attacks, cyber attacks, to even to the cyber physical systems attacks also happening. For example, you can say the smart grid, even like last a few days back also there is a full blackout in Australia, in some part of Australia, because of the attack which happened in the smart grid in that particular place. So that type of attack. So even if a hacker is trying to do some attack in small portion also, that may going to create a very huge impact in the society or to the country also. So there are still cyber attacks which persist in the cyber physical system, though it is gradually increasing. The familiarity or the use of cyber physical systems and the market price is also increasing for the CPS. Gradually, the attacks are also increasing for the CPS. But the CPS have the properties which are impossible with physical design alone. So I can make a physical design, but that physical design alone will not help us to have a very better have a better system. But the cyber physical system will add some better net or whatever things which are not possible to the normal physical design can be improvised using the CPS. For example, the cyber and physical computation and also the dynamics which we are using, and the communication security and safety parameters that we are going to process, all those things make uh, will make the physical design more effective, and some impossible things which cannot be done also be made easily for the people. So for example, you can see these are all some of the applications which normally we focus on the CPS, automotive cars. So in this, more and more components are connected. So we are having some n number of parts within the car. We are using it daily, but we are not aware of it, how much these parts are connected, what is the value behind it, what sort of data it is communicating between these devices. Each and every one is in, it is not just a mechanical part alone or some the electric board or circuits which are connected in the car. Apart from that, each and everything is having some CPS component that is going to be communicated. That is the sensor part, which is going to be communicated among the various components, the automotive devices, automotive things. And in the case of uh, you would have seen the modern high-end car. For example, in this case, we are having more than 100 millions of codes. For example, when you take this car, you can't believe it. There are more than 100 millions of code. Uh, is available for this to communicate between these devices in an automotive, and also it is believed that it is going to be continue to grow in the near future also. In 1 minute. In this automotive, CPS is going to provide a safety critical function. It is going to include some safety critical functions and also driver assistant things and also comfort related things. So nowadays, when you take, uh, uh, we are having more and more high end cars. Even in the high end cars, even if it is fully uh, air conditioned, you can see that when the driver is sitting in the seat, he may be feeling some discomfort. Nowadays, they are having some uh, airflow control also in the seats, so that the driver will not be having the sweating, and he will be able to drive comfortably for long hours also. So those things are also applications of CPS. But when it comes to avionics, we are having two types of avionics. One is going to be the commercial one, the other one is going to be the military kind of thing. So in the case of avionics, in the case of commercial one, you can see, uh, if I wanted to have some onboard connectivity, off-board connectivity, network interoperability, and information architecture or information management, whatever is there, that will be taken care by the CPS. But when it comes to military kind of application, uh, the software intensive systems, uh, high reliability applications, all those things will come into effect. So you can see in the case of military, you can have unmanned air vehicles are also available. We are having different types of classes: class 1, class 2, class 3, class 4, and unattended munitions, unattended sensors, unmanned ground vehicles are available. And then medical treatment and evacuation, FCS recovery and maintenance vehicle, non-line side cannon, non-line slide mortar, mounted combat system, surveillance vehicle, command and control vehicle, infantry carrier vehicle. So these are all some of the manned things, and these are all the unmanned vehicles. So these unmanned vehicles are controlled by the cyber physical systems. When it comes to manufacturing, we can go for some asset management, reconfiguration of the manufacturing devices. We can increase the productivity of the productivity. Uh, when it comes to building, so we can enable the integration of virtual models and the with the physical environment. I know the physical environment. I have designed some virtual environment. How I am going to map these two things, or how I am going to integrate these uh, virtual and physical thing. And in the healthcare, that is in the biomedical thing. So healthcare critical integration of network of medical devices will be taken care. Life critical instruments, context aware computing, like based on a particular situation, how a patient can be treated, and then uh, the system, whatever medical systems we are having, that can be network and that can be communicated. So these are all some of the things which the cyber physical system made the physical devices that are not possible previously to make it possible nowadays. So what is the challenges in working the multidisciplinary area? So we know that the CPS is consisting of multiple disciplines, like different parts of engineering and also healthcare, medicine, everything it is including, finance, everything it is including. So in that case, how we are going to uh, uh, tackle this situation? So this is like some, we have heard about this story when we are young, like some blind people who are looking at an elephant and how they are predicting, like in different positions of the elephant, how they are predicting. It's a fan, it's a spear, it's a snake, it's a tree, it's a wall, it's a rope, like that. Each and everyone is predicting in a different way. Similarly, when we are having an application, if that application has to be made as a smarter device, or if we are going to control it as an automatic one, we have to deal with different domain people. Each and everyone will be having the different views, and those views have to be compiled together to come out with a very good solution. For example, it is going to be a small computer, connected industrial design, it is going to be a big complex system, or it is going to be a robot, or it is going to be an advanced manufacturing, or it is going to be a network, whatever it is. All these things as a one compiled together, we will be having a uh, uh, wearing a better cyber physical system. So this is the CPS architecture. It is going to be a vertical, uh, like we are having different parts in that we are having 5 layers of vertical. Uh, the lowermost, like we are having different functions and attributes also. What are all the functions? What are all its attributes? We will see here. Um, So when we take the lowest layer in the vertical is the smart connection. First of all, we should have a smart connection between the devices, plug and play, tether-free communication or sensor networks. We have to move on it. And the next layer is going to be the data to information conversion. So through this smart connection, I have obtained some data. So that data should be analyzed and it has to be properly communicated to get some information out of it. So when it is going to be a temperature sensor or it is a moisture sensor, I'll be getting some data. But what is that I'm going to do out of that? So that I have to decide on this in the data to information conversion. So smart analytics for component machine health, multi-dimension data correlation, degradation, and performance prediction. So suppose if I am having data from different sensors, so one is going to provide some digital data, one is going to provide some image data. So in that case, how I am going to correlate these data and how I am going to obtain some useful information out of it. So that is taken care by the second layer in the vertical. And the third is going to be the cyber. So in this layer, we are having the twin model for components and machines. So time machine for variation, identification, and memory. And also we will be using this for clustering for similarity in data mining. Suppose if I am having some similar data together means I'll be using some clustering technique to get some useful data out of it. And the next one is cognition. So in this cognition only, we have to make the machine to think like a human being. So it is going to be an integrated simulation and synthesis part. We have to remotely visualize for uh, human brain, and also we have to collaboratively diagnose and take some decision making in the fourth layer. And finally, fifth one is the configuration. It has to self configure for resilience, self adjust for variation, self optimize for disturbance. So for example, if there is some situation where the cyber physical system has to self configure itself, if there is some resilience, it has to self configure, and if there is some variation means it has to adjust accordingly. And also it has to self optimize itself when there is some disturbance in the external atmosphere. So getting the raw data from the sensors and then obtaining some useful information about it, and how we are correlating the data using mining the data, useful information out of it, how we are making it think like a human being. Finally, it has to take some decisions on its own. Okay, these things, when we are just looking at some applications, some automotive application, we can find out how effectively that CPS is working. These are all some of the characteristics of CPS. It has to emphasize more on the technical aspects, the cross-cutting aspects, whatever is the uh, latest domains that it has to address those things, and the level of automation, whether it is going to be 100% automation or it is going to be 90%, that has to be decided, and also the life cycle integration. So once it has completed, how it has to start from the next part. So these things has to be taken. These are some of the characteristics of uh, cyber physical systems. So this is the workflow of a cyber physical system. So when we take, first one is going to be the physical process. So in the physical process, we'll be getting some data which is going to be acquired, and uh, with the help of the networking. So when a sensor is fetching some data, capturing some data, it has to be passed on through some network, and that data will be aggregated in the network, and some valid computation will be done. After doing the computation, it is going to give some result, some valid computed result. Based on that result, actuation will be performed. So once the actuation is performed, it is going to give some control commands to the physical process. For example, you can see a lift. the lift is going to when we are switching on the lift, it is opening. Okay, it is not immediately closing, it is opening, and if it is looking some people in the given range, it is still in the opening position, and if anyone is just hindering also, it is again opening. So like this, that it is going to work on a sense the data at a faster rate, and also compute the data at a faster rate and give the commands at a faster rate. So this is the workflow of the CPS. Okay, so it consists of 4 phases: monitoring, networking, computing, and actuating. Monitoring means collect data and action, give feedback on any past action, and ensure correct operation in the future. And in the networking, data from CPS sensors be aggregated or diffused for analysis to process further. And in the computing part, analyzing the collected data to determine if the physical processes meet preset specific criteria. And the last one is actuating. That is the one which is going to give some action, final thing, executes the action determined during the computing phase. So you can see how the processes are carried out in the physical space. I'm having some data, whatever is obtained, it is going to pass through the networking component to the cyberspace, and then based on some computing, some activation will be performed to the object, whatever object we are having. Okay, it can be like washing machine, fridge, or some switches or mobile phones we can have, or to the house, to the factory, or to the vehicles. It is going to do some actuation. So these are all some embedded computers and networks monitor and control the physical processes with feedback loops. So it has be a continuous process where physical processes affect computation and vice versa. This is the working model. So now let us see some applications of CPS. Okay, first let us consider the first application, CPS in healthcare. Okay, CPS in healthcare, like it vast healthcare devices has come into effect, medical devices and systems. It measures some physiological parameters of the patient's high accurately, image guided and robotic surgery, control of fluid flow for medicinal purposes, and biological analysis, bone marrow or blood transfusion. These are all some of the things where CPS is taken care. For example, a person is like we can take a old people who is at home, and remotely we can monitor the patient with the help of some devices which are tied to that particular patient. It is going to measure the activities of the patient, and it is going to pass on the parameters, whatever physiological parameters. We can take that blood pressure, sugar, all those things, like pulse rate, all those things. It make measure it, and it will be sent to the doctor remotely, and he may give the guidance how to go about. And also sometimes image guided and robotic surgery, remote surgeries also we are taking. Like if some specialist is not available in a particular place, he is in a different country, means we can send the image to that particular doctor, and with the guidance of that doctor also we can do a remote surgery, like that whatever surgery is taken care, that video transmission will be done with the guidance of that expert. We will be able to do that. Apart from that, we are having robotic surgery also, and sometimes we are having some fluid flow of medicinal purposes. We know that anesthesia, all those things we are doing, right? So in that case also we can do uh, uh, control the fluid flow for medicinal purposes and biological analysis in the case of healthcare. Apart from that, we are having cognition and neuroscience systems also, which are based on CPS, brain-computer interfaces, therapeutic and entertainment robotics, orthotics and prosthetic services, map environment images to sound for blind people. So for the blind people, it is going to map the environment, the surrounding environment, and it is going to give some commands to the blind people. So all these things are also some of the applications of CPS in the domain healthcare. So you can see blood pressure sensor, pulse sensor, motion sensor, ECG sensor, and everything is going to be to the coordinator system, and it is going to be passed on through the gateway. With the help of the gateway, it will be reaching the server, which is going to uh, take some necessary action based on the input results. And the next one is about uh, cyber physical system in the field of transportation. So in the transportation, we can go for infrastructure based. So we can go for some real-time monitoring of traffic infrastructure and traffic control. We can use traffic signals, cameras, etc. to avoid traffic control, uh, and vehicle infrastructure coordinator. Suppose transit signal priority, queue warning, ambulance, all those things. Like you can see, uh, uh, many conventional vehicles are going, so we can have communication between these vehicles also, and also connected to the signals, and also to the control room we can have. And here you can see the collision avoidance scenarios. If more number of vehicles are going, how the vehicle to vehicle communication will avoid the monitoring of the vehicles on road, and also how it can avoid the collision. And some what are all the things which are based on vehicle means proximity detection and vehicle health monitoring. So the vehicle the status of the vehicle, warning of vehicle close to another. So you can just, it is going to give some warning sign if two vehicles are very close to each other. And airbag, anti-lock braking, automatic gearbox, smart key, blind angle alert, all those things, the condition of that will be monitored periodically, and that will be intimated to the owner of the vehicle. And in the case of avionics, flight control, anti-collision, pilot information, power supply, flap control, entertainment, all these things will be taken care in the case of avionics. So CPS is playing a vital role in the field of transportation. The next is about smart grid, how the power supply is carried out. You can see smart metering is there. We can have demand side response, renewable energy resources, P2P trading is there. Vehicles are also using energy management, energy efficiency, and home area network. So the smart meters, demand management and automatic distribution. It is going to obtain the information from the end users' load devices and measure the energy consumption of the consumers. Based on their usage, it is going to give the power supply. And also it is going to estimate the magnitude and phase angle of an electrical phasor quantity, and evaluate the regional power consumption. Suppose if in a particular region more power is consumed, how it is going to evaluate it, and it is going to share it. You can see some transition and distribution operation center, power plant, distribution generation, neighborhood aggregated meter. Like I'm having two regions, means how the substation is going to have some control over these two neighborhoods. What is the power consumptions or power phase and measurement units of these two neighborhoods will be evaluated based on the usage. And all these things are communicated through some data, like sensors are there, and each and every device will be having some sensor. Based on that, it is going to be communicated. Like already I was talking about the cyber attack in the smart grids. Okay, if instead of sending one, if they are sending it as 0 also, it is going to affect, create a big chaos in the distribution of power in the neighborhood, in the smart grid. The next one is about CPS in the industries. Okay, in the industries, or we can talk about the manufacturing plants. So how the manufacturing and logistics are integrated with sensors, actuators, and communication capabilities, and also some smart control, smart monitoring and maintenance, optimal resource utilization. The main key point in the implementation of concept of Industry 4.0 is the CPS only. It is having a great potential to enable innovative applications and impact multiple economic sectors in the worldwide economy. So the end products customized specific to customer needs are available. So in this case, you can see there is RFID sensors to identify product and materials provided here, the RFID sensors. For each and every product, there will be an RFID sensor. It is going to identify the product and the material. Some automatic inspection will be going on. Monitor the production flow in real time to eliminate wasted time and reduce in process inventory, and manage equipment remotely using sensors and limit to conserve energy and reduce cost. Even we can manage the equipment from a remote place also. And also the production line triggers autonomous material handling vehicles also. So we can have some vehicles which can handle the material automatically. And also you can implement condition-based maintenance alert to reduce downtime and increase the throughput. So that can also be implemented, and also aggregate the product and process data analyze, identify the constraints and in the improvement areas. So what we can do, we can create some condition-based maintenance, and also we can aggregate the product and process data. We can analyze it and we can identify the problems, and we can try to find out the improvement areas in a particular manufacturing plant. The next one is CPS in agriculture. So you would have heard about the buzzword precision agriculture. In a green farming, greenhouse uh, greenhouse effect, like we'll be doing some precision farming. Apart from that, we can place some sensors in the field itself uh, in some particular topology, and that will be connected to the internet. And through the internet, the control center will be controlling all the activities. Whatever data collected from the sensors in the agricultural field can be done. When we have to fertilize that particular agricultural land, when irrigation can be done, that is when we can do watering, and all those things can be decided. And insecticide spraying, when we have to put mm, uh, fertilizers and insecticide spraying, all those things we can monitor from a remote place in the case of agriculture. So the next comes the Industry 4.0. So we are currently experiencing the fourth industrial revolution in terms of cyber physical systems. These systems are industrial automation systems that enable many innovative functionalities through the networking and their access to the cyber world, thus changing our everyday lives significantly. So you can see the first revolution, like Industry 1.0, it is a mechanization, water power, steam power, everything comes into effect. In the second, in we have second revolution, we have the mass production, assembly line, electricity, everything. In the third revolution, we had the computer and automation. In the fourth revolution comes the cyber physical systems. The foundation of Industry 4.0 was laid during the third industrial revolution that characterized the extensive application of electronics and computers in the third industrial revolution to automate industrial production processes. So the expanding use of these electronics and computers contributed to the declining prices, thus miniaturing and robustness of computers. So when we see the computers in the third revolution, some cases you would have seen the very bigger in size, but nowadays miniaturization has come into effect. Even the phones, mobile phones, when it was introduced in the beginning, it was very larger in size, and then it has come in very smaller sizes. But the properties or the characterization are the functionalities are more when compared to the previous ones. So how the industrial revolutions through the ages have occurred means, you can see in 1.0, the industrial revolution begins. As I told you about the mechanization of manufacturing with the introduction of steam and water power. The steam engine and steam engine have come into effect, and then comes the mass production of assembly lines using the electric power. Electric vehicles have come, and then in the third we have a change to automation, and in the fourth one it is going to be a smart factory. decision making of cyber physical system using machine learning and big data analytics. So the interoperability through the IoT and cloud technology come into effect in the effort into the from 2000 in the industry 4.0 revolution. So the generation of mechanical power from water, steam and fossil fuels were done in industry 1.0. The electrical energy was favored by manufacturers with assembly lines and mass productions in industry 2.0, and familiarize the production industries with the concept of automation in industry 3.0, and utilizes the IoT cloud computing for provision of real-time interface between the virtual and physical world in the industry 4.0. Some of the key facilitators of industry 4.0 are the Internet of Things. Uh, the next one is machine learning concepts, cyber physical systems, cloud computing, big data analytics, cyber security, and additive manufacturing. So the important aspect of industry 4.0 is automation. No human intervention or minimal human intervention. That is the buzzword in industry 4.0. And the entire production line should be autonomous. Uh, Sensors, actuators, communication, automation enabling technologies for industry 4.0 come into effort in the industry 4.0. So this industry 4.0 applies IoT in the manufacturing workspaces, then analyzes the big data collected on the cloud storage to efficiently increase autonomy and cybersecurity levels. So this is a cycle, these are all some of the key facilitators for a successful automation of industry 4.0. So what are the key elements that has to be considered means asset utilization, quality control, supply chain management, product monitoring, and workplace safety. These are all some of the key elements that has to be taken care in the case of industry 4.2. That is, here machine to machine communication is done, advanced analytics is taken care, and we are using only the ubiquitous internet. And these applications and techniques, how it is carried out at each level. In the traditional view, we are having data flows from bottom to top, intelligence and decisions from flow from top to bottom. In the changed view, much intelligence and decisions are generated at the bottom. Only general policies are set at the top, and reports on overall performance are generated. For example, you can see in the case you just consider the bottom layer. Excuse me. In the case of consider the bottom layer. 1 minute. Are you all able to hear me? Sorry for the disturbance. In the bottom layer, it is the connection. You all able to hear me?
Yes, ma'am. Yes,
Okay,
ma'am.
okay.
It's audible to all. Yes, ma'am.
Okay, fine. Thank you. Okay, just consider the bottom layer, the sensors. We are having different types of sensors. We have to go monitoring. So based on which condition, like suppose if it is agricultural, we have to choose that suits the particular agricultural scenario. When it is going to be a traffic monitoring, we have to choose a particular thing. So that is going to be the sensor selection. And the next one is going to be the machine or components, like whatever diagnostic we are making out of it, the information which we are going to take out of the machine components. The third one is going to be the cyber thing, that is cyber physical systems, how it is going to be monitored peer to peer, peer artificial intelligence for time adapt analysis, how it's carried out, and how our the sensor data obtained from sensor is going to take some decisions in the fourth layer. And the final one is going to be the supervisory control, which is going to take some actions. What are the actions that can be taken place, or what are the actions that has to be avoided to have a better application. So in this industrial revolution, we can see that manual power to artificial power and then artificial intelligent power. Now, just artificial power alone is not working out. Now we are having that artificial intelligence power. That is, all the human efforts are decreased, but the comforts are increased, and the productivity time is reduced, and productivity is increased. That is the thing. So in the normal machinery level, manual power that which was converted to artificial power, we are using the artificial power, and then in the machineries, artificial power in the machineries. Uh, Artificial power in the machineries. Now we are going for artificial intelligent power. Okay, now we are having robots. The robots are thinking like human beings and they are working like humans. So how this revolution transfer, like in Industry 4.0, we are having different revolutions. Different revolutions are started. Like in the previous days, how transportation was carried out, and then in the middle ages we have, that is the second industry, industry 2.0, we have like this, and now we are having uh, the smart cars. Each and every car is monitored. You can see that circles around each and every car, so it is having the region of interest. Within that we are having their details, and we are having some self-driving cars. So automatic driverless cars are also coming to effect. This is a manufacturing video automatic manufacturing system. So in this video, you would have seen that how a product from the scratch it is uh, designed until it reaches a logistic, how it is done, even the quality control, everything is done automatically without any human intervention, uh, packing, and then it reaches the vehicle for transport. So like this, CPS is involved in the case of manufacturing. This is for some company by name Delta. For that company, I have shown the video. Uh, like different applications like we are having the automations. So these are some of the functional implementations of CPS, how it is done. Like when we wanted to do some what is CPS, what are the things we can do with the help of CPS, we can see that we can work on some data management part or data analysis part or some decision making analysis, cyber world decision making. You can see you can see this RFID. This is the first part. RFID sensors are there, and the data is passed on uh, through the network, and based on the decision, it is going to actuate. How it is done is that whatever data we are having, that it is going to be analyzed, passed on to the cyber world, and then decision is made, and the control is passed on to this shaft to actuate a particular kind of thing. So these physical resources, ubiquitous apps and services are carried out, and also the sensor actuators are necessary to interact with the physical world. So the intelligence comes only from the data with sensors and actuators changes in the physical process, conditions or performance as changes in value user. So the another thing is we are having certain design challenges in the CPS, the design abstraction, safety, integration, timing, predictability, composability, and software models. When we take the design abstraction, it is very hard to predict that the cyber part will meet the requirements of the physical part. Uh, for example, if I wanted to create a smart classroom, first of all, I should uh, analyze the physical classroom. What are all the things, what are all the needs for that particular physical class, and what are all the expectations of the end user and also the service provider. And based on that, only we'll be able to create a particular uh, uh, cyber part. And abstractions do not directly encapsulate characteristics of the environment. Sometimes we'll be able to design, but we'll not be able to put all the physical part into action in a part. So that is the main uh, uh, problem, main challenge in the design thing. And the next one is about safety. So hard to guarantee in interconnected and interdependent systems. So we know that in cyber physical systems, each and every device is communicating with other devices. We cannot trust the communication channel and users, and also formal verification and certification has to be done. So there may be a possibility of intruders to change the data. Like for example, if there is a house alarming system, automated house alarming system. So in that case, if there is any mm, natural calamity or certain thing, if that system itself is damaged, we will not be able to uh, get the actual output out of that. So the safety is also one of the challenge in designing a CPS. And then the integration part, putting the system together is much more challenging than implementing the individual system. So we are dealing with different uh, parts. Okay, so in that case, a different application. So it will be very difficult for us to integrate the multi-domain thing. So that is a challenge. And then time predictability. So we have to ensure the computation always finishes within the guaranteed time. And also it has to give a correct result at right time. So that is one of the main challenge. And the next one is composability. So in this case, we have to deal with the interrelationship of components. Main issue is hardware and software resources shared among multiple subsystems. We are sharing many hardware and software among different devices. So we have to deal with the relationship of the components, and also the software models for interdisciplinary fit is also great challenge. So this is one another example of advanced driver assistance system. This is also belong to one company, Billington. You can see So when you take this uh, automatic driver assistance system, it's not a complete driver assistance system. It is just a glass manufacturing system. How they have done that, I'll show you. Sorry. So finally, these are all some of the technologies under CPS. So even if you want to do some research or some projects related to CPS, we can't do for an entire CPS when we are in the education field. We can focus on certain things, like we can focus on nanotechnology, or we can focus on Internet of Things, machine learning, virtual reality, communication, blockchain, computer vision, natural language processing, smart sensors. Like that, we can take certain technologies and we can do some applications related to that, like agriculture or manufacturing uh, or automation. Like that, we can focus on certain application, taking any few of this any one of this technology to do research. Uh, so I hope this session
Thank
was
you.
useful.
Yes, ma'am.
Uh,
Thank you, ma'am.
finally,
Audience, any queries? Audience, from audience side, any queries? Yes. Even you can post the queries in chat box too, students.
okay. Thank you, ma'am.
Okay,
Shall I
thank you,
leave
ma'am.
or shall I?
Yeah, okay, ma'am. You can leave, ma'am. Thank you,
Thank you
ma'am.
so much.
Yes, ma'am.